welcome everyone for the international conference and members meet organized once again by WRS, with the World Research Society in association with IRF Research Forum and other organizations. So talking about IRF Research Forum and World Research Society, it's world's largest non-profit organization meant for conducting the members meet and international conferences and members meet and international conference like this. So talking more about the organization, organization is a decade-old organization. It conducts conferences every now and then, and basically the when it comes to number games, organization has conducted more than more than 700 plus national conferences and international conferences, and about 1 lakh plus people have been associated, and more than 50,000 papers has been published in the journals. And we have around 10 journals, 10 international journals associated with us. I mean, our organization, 10 international journals are there in various fields of science, engineering, management, psychology, medical sciences, and many more in all the interdisciplinary field. We have 10 international journals indexed in very good with a good impact factors and nice indexing. So these are some of the add-ons of the organization's reputation of this decade-old organizations. So with this, I would like to welcome everyone wholeheartedly, and we'll quickly go ahead with the presentation. We have around 14 presentations. I hope other 2-3 more yet to join, though with listeners and presenters yet to join. But anyhow, instead of waiting for them, we'll quickly go ahead and start with the conference. So with this, we will start up with the presentation. Before starting the presentation, I request everyone to kindly turn on your video. We can take up a quick group photo. Right.
Thank you. Hello, everyone. So now I want to tell you about my research. The title is Analysis of Fish Waste and Co-Substrate Mixture on Biogas Production and Solid Waste Reduction in an Aerobic Digester. This is the table of content in this presentation. I'm Ivanur Faiz. I studied at Environmental of Engineering Master Program, Department of Civil and Environmental Engineering, Faculty of Engineering, Universitas Indonesia, Depok, West Java, Indonesia. This is my introduction. There are so many potential in Indonesia. First, Indonesia is a maritime country dominated by 77% of its territorial waters and 23% of its land area, with 17,504 islands. The second is there were approximately 62,088 fish processing units spread across Indonesia in the form of micro, small, and large medium enterprises. And then there are so many potential of fish waste in Indonesia. First, fish waste management in Indonesia has not received much attention up to this point due to the country's generally still fairly conventional approach to fish management. Second, the management of marine product fish waste is the biggest problem because fish processing waste has a proportion of 30 until 40% of the total weight of fish, consisting of heads, bones, fins, skin, and ovals, while liquid waste can come from fish blood and fish wash water. There are so many processes to treat fish waste, but I choose anaerobic digester because this is the simple technology, and we can convert from waste to another energy like biogas. And then this is the research to support anaerobic digester technology. First, based on the findings of research by Kadafit, the analysis result estimate the annual energy production generated from using 509 tons of fish waste, producing 489 megawatt per hour of energy that can satisfy 230 fishing families. And second, based on the result of research conducted by SODIC, using two variations of the substrate mass composition of organic waste and fish waste in reactor A and reactor B, the average result results of biogas production and methane gas in reactor A and reactor B are biogas volume of 69 liter per kilogram Vs and 67 liter per kilogram Vs. And for methane yield, for reactor A is 11 liter methane per kilogram Vs, and for reactor B is 8 liter methane per kilogram Vs. And so what barriers does this waste present? Yeah, high concentration of ammonia and long chain fatty acid found in fish waste could lower the production of methane gas during the anaerobic digester. Set of the biogas production process in anaerobic digester, consequently resulting in low CN circumstances. In this research, I use I'm not just use fish waste because fish waste just have CN ratio 8.65. So I combine with another substrate like food waste and then cow dung and sawdust. And then the research objective is the study aim to evaluate the anaerobic digester process in terms of solid reduction, biogas productivity, and performance. And then this is the methodology. This is the reactor design that I use. The reactor was constructed out of cylindrical fiber, and then the reactor is divided into two parts. Both parts are separated by a diaphragm to separate the substrate that has not been processed at the bottom and the substrate that has been processed at the top. And then the research methods, there are 4 steps. First, this is the preliminary study, testing of the initial characteristic of the substrate for parameter total solid and volatile solid. The result you can see at the table on the screen. And then the percentage ratio of the composition used in this study in order for reactor A is 40 for fish waste, 40 for food waste, and 50 for cow dung, and 5 for sawdust. And for reactor B, 30 for fish waste and 30 for food waste, and then 20 for cow dung and 20 for sawdust. And for organic loading rate that I use in this research is 2.5 kilogram Vs per meter cubic per day. And then this is the formula for calculate the substrate mass. And then this is the result of the substrate mass calculation. For reactor A, the feeding amount is 8.89, and for reactor B is 6.29. And then I test the CN ratio 2. The result is for reactor A is 27.40, and for reactor B is 35.38. And then the second step is acclimatization process. The acclimatization process took 5 weeks. For example, week 1 is 20% from a feed amount, and then 22, 40% for feed amount, until week 5, 100% from feeding amount. And then the third is operational and experiment process. It took 3 weeks. With the feeding process is carried out 5 times a week. And then the research data analysis that I use software IBM SPSS Statistic 25. And then this is the result and discussion for the temperature parameter. The conclusion is the comparison of temperature measurement in reactor A and B show a difference that is not much difference, but substrate measurement at the input and output points. And for pH parameter, the conclusion is the comparison of pH measurement in reactor A and B show a difference that is not significant from both substrate measurement at the input and output points. And then this is the result of total solid and volatile solid from reactor A and reactor B. And then And then we can get total solid reduction from total solid input and total solid output. And then this is the result of total solid reduction measurement. The total solid reduction in reactor A has an average 97.42%, and for reactor B has an average of 97.95%. If we compare with research by Sodic, which only use food waste and fish waste substrate, may have lower reduction value than the result of the two reactors. It's same with the volatile solid destruction in VSD, and reactor A has an average 67.87%, and for reactor B has an average of 54.80%. And then this is the result of the biogas composition. For reactor A had an average methane content of 64.19% and average carbon dioxide of 35.57%. And for hydrogen sulfate, 0.24%. And for reactor B has an average methane content of 64.12% and carbon dioxide an average 35.79%. And for hydrogen sulfide is 0.08%. And then this is the biogas volume. We got in reactor A, produce biogas on average 155.8 liters per day. And for reactor B, produce biogas on average 133.56 liters per day. And for methane yield calculation, we got in reactor A, we got 122.37 liter methane per kilogram PS. And for reactor B, we got 131.76 liter methane per kilogram PS. So the conclusion is, based on this research, it can be concluded that processing into biogas with an anaerobic digester method using substrate of fish waste, food waste, cow dung, and sawdust at a composition ratio of 40-40-15-5 and 30-30-20-20 can be done effectively. It can be seen from the solid that have been reduced to 97.42% in reactor A and 97.95% in reactor B, and generate 150.8 liters per day of biogas in reactor A and 130.56 liters per day on biogas in reactor B. And the second reactor A yield an average of 122.37 liter methane per kilogram PS, and for reactor B yield an average of 131.76 liter methane per kilogram PS. The result of the research indicated that there is not a significant difference between the composition ratio in reactor A and reactor B with regard to reduction, biogas volume, or methane yield. And then as the result, the two composition ratio can be used to determine the composition of waste treatment using an anaerobic digester. This is the documentation of the research. Thank you for the attention.
From the University of Port Harcourt, Nigeria. I'm here to present my research of an extract of my PhD work, which is an optimization of process parameters in the development of green composite ceiling board from chicken feather and sawdust. Yes, background to this study. It is observed that in the building industry, we have components of sealing materials that are not friendly to the environment. They are not biodegradable and they pose threats. Just as it is said here, conventional sealing was like asbestos, which has been banned, but in the developing countries, you see that they are being used in-house in their homes, and they have materials, compositions that are carcinogenic, and we have PVC. PVC have these defects of the fire resistant quality is very poor. We have POP, which absorbs a lot of water, and these three sealing boards, sealing materials are mostly used in the society. And looking at our waste disposal, we understand that in a quest to convert waste to wealth, we have a lot of waste, agricultural waste, organic waste that have been disposed in landfills, and then they pose threats to the environment, such as we have sawdust. They are disposed in water bodies, disposed and burnt. If you go to timber shops, timbers, and you see that there are no specific method of disposing sawdust. Even chicken feathers, they are burnt. They are disposed in landfills. Also, we have a lot of them, like rice husk. They are also disposed on landfills. So this research is to convert this waste materials, organic materials, into sealing boards, sealing materials, to curb these defects of conventional sealing boards. So in this study, we have a lot of organic waste materials like granite peas that are being used. These are the most commonly used organic wastes in the society today. In research to convert them into sealing materials and other composite materials like granite peas. We have corn cob gotten from corn. We have palm kernel shells that are gotten from palm kernel. We have coconut core. They are all fibers. We have rice husk. We have chicken feathers and sawdust. For the purpose of this research, we are using the chicken feathers and sawdust to make to produce this sealing board that will curb the defects of these other conventional sealing boards. So for this experiment, we have the materials that are being used. They are chicken feather, which is the base material. Chicken feather and sawdust are the base materials. We have sand, which is used as fire retardant to also fight the defects of PVC. We have mono ammonium phosphate, which is also a fire retardant. You can also call it a fire extinguisher powder. We have the resin, the hardener. We have a methyl ethyl ketone, which is used as the accelerator. Then calcium carbonate as filler, and copper filings. For this experiment, box-banking design of experiment was chosen, and the coded equations for X1 represents the materials, X2 represents the curing time, and X3 represents the curing temperatures. And these are the process variables and the coded levels. From the coded equation, we have this for curing time. So they are used for box-banking design of experiment. A 3 factorial design was chosen, which is low, medium, and high. For the materials, the low is 35% by weight. For medium, 45% by weight of the base materials. Then for high, 55% by weight. While the curing time, we use 60 minutes, 120 minutes, and 180 minutes. While for the curing time, for curing temperature, we have 100 degrees Celsius, 150 degrees, and 250 degrees. Now, this is a box-banking design for 3 factorial, 3 by 3 factorial. It runs, we have 15 runs, and these are the results gotten from flexural rigidity, water absorption, and density, because this research is basically dealing with trying to solve the problem of rigidity water absorption, density, and the thermal stability of conventional sealing boards. Here we have the results of those samples. From these runs, we conducted 15 experiments, which is shown here. 15 of these experiments from post-banking designs, and 15 samples were gotten. And from the 15 samples, tests were conducted on them, which are this: flexural water absorption and density. These are the various results for each of the samples. Now for run one, it represents low, low, and medium. So they are designated as low, low, medium, low, high, medium, and so on. These are also the continuation of the results from the runs, the experiment. Now, the experimental work, after getting the box banking design of experiment, the process was sawdust was gotten from timber shops. It was grinded into particles, sieved with the 250 microns of sieve. The chicken feathers was also gotten from chicken abattoir, where they kill chickens and where the feathers were disposed. They were gotten, washed, dried, and put and sieved into and put it inside the milling machine. It was grinded into particles, of which we have chicken feather particles and sawdust particles. They were not added with proportion, the right proportion of the silicon dioxide, the sand, the monoammonium phosphate, calcium carbonate, copper filings, epoxy resin, and hardener. The epoxy resin, the ratio is 2:1 for the epoxy and its hardener with the MEK, methyl ethyl ketone. They were combined, and we got from their combination and from the production, we have an eco-friendly sealing board. You can see this green composite sealing board. This is a sample of one of the sealing boards that was produced. And after production, they were cured in the proportion of the right way, proportion of the curing time, curing temperature, according to the runs, as it's seen here, according to the runs. Now, a multiple regression equation was carried out, was done to get the relationship between these process parameters. Between the curing time, the curing temperature, and the base materials. Beta 0 represents the modal constant, while x1, x2, x3, they are the independent variables. Beta 1 and 2, 2 and 3 represent the linear coefficients of this, and this beta 1, 2, 2, 3, they are the cross product coefficients. So we move down to the parameters analysis. After this was done, the experiment was okay. The parameters analysis: flexural rigidity, water absorption, density, and thermal stability. These tests were conducted in ASTM standard methods that are shown on the slide. So for flexural rigidity, the maximum load, the span length, and the width with the thickness were taken and calculated. For water absorption, it was weighed in air, then soaked in water for 24 hours, then reweighed. Then with this calculation, the water moisture content was gotten. For density, we have, according to this formula, the specific gravity was calculated based on the mass of sample in air calculated, mass of sample and sinker in water calculated, and with this specific gravity equation, we got the density, which was multiplied by 997.6. Then the thermal stability, a TGA test was conducted on all the samples using Perkin Elmer TGA 4000 thermographic. Now this is the results gotten. From the results, another table was also used to calculate the results, and we discovered that from this table, the materials has the most effect on the flexural rigidity of the sample. Now we have from the results from this table here, from this graph, response surface methodologic graph, we have 1.6921 megapascal of the flexural rigidity as the optimal value gotten from this process. It was gotten at 35 percentage by weight of the base material, chicken feathers and sawdust at 200 degrees temperature, cured at 200 degree temperature at a time of 60. We have the results for water absorption. For the water absorption, it's also discovered that the base material have the most effect on the water absorption properties, and it is 16 to 22% of its absorption rate when it is cured at 120. It is cured at 120 degrees temperature and at 60 minutes. So we discovered that the maximum is at it absorbs is 46%. Now the ANOVA table for composite density also describes that the density, the based material, which is the X1, has more effect on the density. This explains the fact that mass has more effect on the density than the curing time and the curing temperature. And the maximum density, optimal density, recorded for 640 kilometer per meter square. That is the optimal density gotten from this experiment, which is gotten at when cured at 35 degrees, 35 percentage by weight of the chicken feathers and sawdust at 180 minutes with 200 degrees centigrade of the temperature. Now, for the effect of the thermal stability, the optimal value, the optimal sample that was gotten was the sample produced sample 321, which means a high materials, which is 55 percentage by weight, cured at 200 degrees at a time of 120 minutes. Now, these are the weight loss percentage. This is the graph. This is a TGA graph that shows the decomposition rate of the sample. This is for the optimal samples. Compared to other samples, this produces the optimal samples. Conclusion. Using benchmarking and ANOVA analysis, the study optimizes these three parameters: the selected material, curing time, and curing temperature. Why the results gotten for density, we have that for density to get the optimal value, 55% of weight of the base materials should be cured at 120 minutes, should be cured at 200 degrees for 180 minutes. While for flexural and water absorption, the base material should be 35 percentage by weight, cured at 200 degrees temperature for 60 minutes, while the thermal stability produce 55 percentage by weight concentration of the base materials to be cured at 200 degrees temperature for 120 minutes. Thank you very much for listening. Thank you.
Hello, everybody. So I will present to you today my work entitled Trajectory for Wireless Charging in a Wireless Sensor Network. So I began with an introduction, the principle of our approach, and then I introduce the spice filling curve. Next, I will present the optimization approach adopted in this work. Then I will present the Hilbert curve for wireless charging that we used in this work. And after finally, we conclude our presentation. So here we have a schema of a wireless sensor network. So the primary goal of WSN or wireless sensor network is to gather and route the sensor data by sensor node to the sink. The energy is consumed mainly in the communication task, and multi-hop communication is required for sending data from source to the sink node. As a result, nodes nearest the sink consume quickly their energy as relaying node. The solution to overcome this last problem is to deploy multiple sink or to organize sensor field in cluster or to use a mobile sink able to move in the deployment space to collect the data recovered by the sensor nodes. And in this work, we use this mobile sink to charge the sensor that deplete their energy. So in this work, the sink acts double action as a data collector and as charger. So the energy is the most important resource in a wireless sensor network since each node collects, processes, and transmits data to its base station. Those tasks will cause the energy depletion, which will lead to the inability to complete the network tasks. To overcome this problem, the wireless rechargeable sensor networks, WRSN, have been developed to prolong the lifetime of the entire network. In WRSN, a mobile charging is responsible for wireless charging each sensor battery using a wireless power transfer system. In this case, it's a radio frequency. This work proposes trajectory for the mobile charger based on the Hilbert curve. So wireless charging in a wireless sensor network is a technology that allows the replenishment of energy in a sensor node without the need for physical connection or battery replacement. WSN consists of small low power sensor nodes that are often deployed in remote or hard to reach area for various applications, such as environmental monitoring, surveillance, and industrial automation. Those sensor nodes are typically powered by batteries, and one of the significant challenges in WSN is extending the operational lifetime of those nodes and as a result, the lifetime of the entire sensor, the wireless sensor node, which is limited by the finite energy stored in their batteries. So here we have a mobile charger that transmits the energy wirelessly by radio frequency to the sensor node that energy is experienced. So the energy is captured by a receiving antenna and rectified into a working direct current voltage. Here we have an RF energy harvesting system figure. So we used the space filling curve that the sensor, the wireless mobile charger have to follow this trajectory. So the Hilbert curve is a continuous fractal space filling curve first described by the German mathematician David Hilbert in 1891 as a variant of the space filling curve discovered by Gustave Pinot. The Hilbert space filling curve is one-dimensional curve which visits every point within a two-dimensional space. Here we have a curve of one dimension, two dimension, and four dimension. So our approach is based on the following step. First, we have to deploy the sensor node in the sensing field, and then we have to form a clusters, and then we trace the trajectory based on Hilbert curve, and the mobile have to join the sensor, the clusters, by following the trajectory of the Hilbert curve. The fourth steps is simulation, and then we have the evaluation result. So here, as our project is at its beginning, we have no results yet, okay? Donc, here we have a sensor, donc, red point deployed in a sensor field, and every bold square represents a cluster, and the center of the cluster represents the decision point of the mobile charger that is act as mobile charger and sync and as the sync to collect data. So here we have the mobile charger, and he will follow the trajectory of Hilbert curve. Sorry for the animation because I have no PowerPoint in this personal computer. So as conclusion, wireless charging in WSN helps increase their autonomy and reduce the need for frequent maintenance, such as battery replacement. However, there are challenges to overcome, including optimizing the energy transfer efficiency, designing energy efficient sensor node, and developing suitable charging infrastructure additionally. The choice of the energy harvesting method depends on the applications, environment, and requirement. Thank you for your attention.
Share about hope and school belonging. My co-presenter, Patrick Cunningham, unfortunately was not able to join me, but he did contribute to this, and so I wanted to make sure to give him credit as well. The presentation today is about hope and school belonging because my field is looking at mental health issues of children and adolescents in the United States, but also around the world. And mental health issues for children and adolescents and adults has increased exponentially over the last decade, but especially during and after the pandemic. So in the United States, specifically, more than 40% of high school students, which are usually adolescents aged 14 to 18 years old, report feeling depressed and hopeless. So hopeless that over the last couple of weeks that they feel like they can't do anything. About 22% of these adolescents have seriously considered attempting suicide, and 1 in 10 have reported attempting suicide. Anecdotally, not in the presentation slides, but emergency room participation, I guess, or reports of adolescent females have increased significantly during and after the pandemic as well for suicidal ideation. Across the globe, a study in 2020 looked at a multitude of studies examining the impact of the COVID-19 pandemic. Across all the studies that they looked at, they determined that reports of anxiety and depression have approximately doubled for the 80,000 participants in these studies around the world, with about 20% or 1 in 5 of the participants experiencing anxiety and about 1 in 4 or 25% experiencing depression. So the mental health issues of our children, adolescents, and actually adults as well, reports of anxiety increased about 300% during the pandemic. And so the mental health of adults, children, and adolescents have seemed to significantly worsen over the last decade, and the pandemic also had an impact on that as well. So my particular field is with counseling and counselors that work in schools. We work with teachers, and we work with educational administrators, we work with leaders to address mental health issues of students, specifically children and adolescents. So children as young as 5 years old, all the way through 18 years old. So when we talk about ways that school counselors can respond, what I'm reporting now is research that is not often widely known or used in the United States, and I have not found it to be used across the globe as much as to buffer the impact of the mental health issues and the traumas that our children have experienced in schools, in their communities, and as a result of the pandemic. So one approach that seems to be well supported in the research is to increase protective factors. Protective factors refer to a variety of different things that seem to buffer the impact of traumas. In some, or in a generalization, they tend to be around relationships and positive relationships. and the ecology of the environment in which the students or the children are interacting at school. So counselors can provide interventions. They create interventions at the school level or at the classroom level or a small group level or even individual level that foster feelings of hope and school belonging. Again, these are two factors that normally hope especially really isn't something that is well known across the United States and as far as I know globally. School belonging is more likely to be known and focused on in the United States, and it has a myriad of different names that people use to refer to it. There's a robust research base around these two factors, suggesting that they increase students' overall well-being and also protect against the harmful ramifications of trauma, such as that students have experienced during the pandemic. They also produce positive student outcomes. In the United States, and I know in some other countries, academic outcomes is the priority, and oftentimes in the United States, schools don't focus on the mental health outcomes, and the academic outcomes suffer as well because of the mental health issues the students are facing. So if we address mental health issues, then consequently academic issues are removed or reduced, and academic achievement increases. So for our presentation today, the hope is defined as goal-directed thinking. There's specifically two things involved with hope, which is pathways and agency thinking. There's some phrases that people use. Also, they may call it way power for pathways, like are there ways that people can move forward, and willpower to reflect agency thinking. Does somebody have the will to move on those pathways? The two factors together combined create hope. So the students that apply hope to the work, they can see ways to move from where they are now. One of the phrases that one of the researchers uses, you can get there from here. You can get wherever you want to go, your goals, you can get there from here. They can see a pathways to attain their goals. They can see a desired future that they can attain, and they can perceive in themselves the capacity to achieve those goals and navigate the pathways. So when students apply hope, they can achieve their personal goals or academic goals. This is true of adults as well. So hope there's an adult hope scale as well as a children's hope scale. So you can measure hope with the Snyder Children's Hope Scale. You can also measure hope in adults. So we can measure our own levels of hope and increase them actually quite easily. So school belonging. When students experience high levels of school belonging, it leads to positive academic and developmental outcomes. So there's a lot of research around school belonging, mostly because it's been used interchangeably with other terms like school connectedness or school engagement, school bonding, feelings of school community. So a long history of research in this area. So the definitions to which we'll use today is just how much students feel accepted, respected, included, and supported by others in the school social environment. So top-down schools are schools that are very hierarchical or very almost like you might imagine like a very structured school where students don't feel like they're accepted or respected. They're going to have lower feelings of school belonging. So if you have high feelings of school belonging, it's most likely because you have a very healthy relationship between peers. Students really feel like they get along well with their peers, but also very importantly with their teachers. They feel like teachers treat them fairly. They get along with their teachers. They feel safe at school. They feel like the school is somewhere they want to go to. If that happens and school belonging is, there's high feelings of school belonging, it helps buffer the harmful impacts such as depression. It can reduce depression. It can reduce emotional distress. It can actually reduce loneliness and consequently increase self-efficacy, self-esteem, and life satisfaction. Belonging is a protective factor, and along with those kind of holistic wellness areas and reduction in mental health areas, it increases academic outcomes as well. So the hope of this research in this paper and this presentation is really to encourage those that are exploring this field and the field being education as a whole to consider mental health as a core area of focus. A lot of times we work with administrators in schools, they're focusing so much on academics or achievement that they're neglecting the holistic health. It's not true in all countries. In some countries that I visited, the holistic health of students is the focus. What's beautiful about that is when you focus on the holistic health of students, the academics naturally follow. The converse doesn't apply. If you focus only on the academics, the mental health does not follow. The mental health does not improve. In fact, the mental health can obviously deteriorate. So it's beneficial to the educational leaders to focus on holistic health because they also get the academic outcomes that they need, as well as providing benefits to the students. So counselors in schools and educators can support counselors in schools to provide interventions, as I mentioned before, at lots of different levels, the whole school level, a small group level, individual level. These interventions, some of them already exist. You can go in and find them, like Marquise et al. In 2011 have a list of existing interventions, or you can develop your own. And as long as they create kind of goal-directed work, the goals need to be set by the students themselves, not by adults, though. That's kind of key. We can't go in and tell a kid, you need to do these goals. It does not help their mental health. But if you help a student develop their own agency and pathways and create positive peer relationships, it can result in a general well-being for that student. So another really positive thing is school belonging and hope are related. So when you build hope, it also builds school belonging and vice versa. So you can incorporate goal setting and pathway creation interventions that create hope, and it can also then consequently create school belonging. And so the implication or my goal out of this is that educators and counselors work together to really focus on building hope and to foster those positive student-teacher relationships and peer-to-peer relationships because it helps kids build coping skills and self-efficacy to handle the mental health issues created by the pandemic and that have been worsening over the last decade. If they increase the feelings of school belonging, then we can reduce the mental health issues and we can increase positive outcomes holistically. So I appreciate it. Again, I'm Dr. Brett Zaromsky. I'm an associate professor and the program chair in counselor education at The Ohio State University in Columbus, Ohio. I'll put my contact information in the chat. I appreciate the opportunity to share today.
And my research is all about a deep learning-based mobile application framework for classifying rice crop diseases in Labocamarines. So for the contents, I have here the introduction, problems encountered, objective of the study, results and discussion, proposed architectural framework, and conclusion. So I'll begin with the introduction. As the world population grows, the demand for basic foods like rice is very important in global nutrition, and it ranks high among many crops worldwide. However, several diseases and pests harm these crops, particularly in high temperature, high humidity, and abundant temperature in the Philippines, and such as the impact of viral, bacterial, and fungal infection that reduce rice quality and quantity, leading to serious challenges to the global economy. So for the problems encountered during my interview with the participants, such as the DOA or Department of Agriculture, the coordinator, agriculture coordinator, and the farmers as well, there are 3 problems encountered, such as insufficient information about the specific rice crop diseases. Number 2 is time-consuming in waiting for the results of tested rice crop leaf samples and difficulty in early disease prevention on rice crops. So I will discuss each of the problems to you guys. And for the insufficient information about the specific rice crop diseases, this you can find it in my paper in the introduction paragraph number 3. There are actually 12 types of diseases that agronomists can identify, but agronomists also stated that there are diseases which are difficult to identify, such as 2 bacterial diseases like bacterial leaf blight and bacterial leaf stick. And then there are also viral diseases including grassy stunt and yellow matter tumbro virus, and other diseases such as leaf spot, powdery mildew, and false mat. While farmers have reported difficulty detecting other additional 2 diseases such as rug stunt virus and bakani without the assistance of rice crop diseases or professionals rather. Then for problem encounter number 2, for time consuming in waiting for the results of tested rice crop leaf sample, You can find it in my paper under results and discussion table number 1, which is the existing issues and problems encountered. So the DOA, or Department of Agriculture, takes time to visit 52 barangays, which is the smallest administrative division, and the 3 barangays per month, especially on large farms. While the farmers takes 2 to 5 days to test rice crop diseases before responding to farmers' concerns. And for the problem number 3, which is difficulty in early disease prevention and rice crops, farmers and field coordinators stated that there are difficulty in identifying and classifying some rice crop diseases for early disease spread prevention from one crop to another. So those are the 3 problems encountered in my study. And for the objective of the study, the objective of this study is to present the model overall framework for rice disease identification and classification using a learning-based convolutional neural network model running on a mobile application that will eliminate all the issues presented, such as insufficient information about the specific rice crop diseases, time-consuming in waiting for the results of tested rice crop samples, and difficulty in early disease prevention on rice crops. And for the methodology, the researcher used the qualitative approach. This qualitative approach is for the focus group discussion, which I chose some of the participants contributed to the focus group discussion via online meeting. And for the purposive sampling, the researcher used also choose the respondents, such as the Department of Agronomists or Agriculture, the agronomist, field coordinator, and the farmers. And for the third methodology, the researcher used an in-depth informal interview, which conducted to gather additional information for the construction of an architectural framework. And lastly, the researcher decided to create a flowchart and block diagram. These were to use in the system methodology for developing the architectural framework. So for the results and discussion, I have there the indicator, response, and action taken. For the indicator, I have there the monitoring of rice crop diseases, identifying, classifying rice crop diseases, and prevention of rice crop diseases. For the response, for the monitoring, the agronomist visited monthly or gathered monthly visitation and training in 3 barangays. For the action taken, they discussed the needed materials, fertilizers, farm equipment, and field consultation. For the identifying, classifying of rice crops, the farmers and field coordinator identifies the disease based on their experience only, but are limited because they cannot identify other diseases as mentioned earlier. And for the action taken, diseases that are difficult to identify are presented by the farmers, and they get the sample leaf from the field and then tested by the DOA laboratory for testing. And then for the prevention of rice crop, the Department of Agriculture suggested to use fertilizers needed for growing seeds and growing seasons, but the distribution of fertilizers are given only if it is available. So this table presents an existing process of monitoring, identifying, classifying, prevention of rice crop diseases. For another table, I have there the person involved. So the DOA, farmers and field coordinator. For the DOA response, it takes time to visit 52 smallest administrative division, and especially on large farms. While in farmers and field coordinator, it is difficult for them to identify and classify rice crop diseases for early disease spread prevention from one crop to another. And it takes 2 to 5 days to test the rice crop disease before responding to the farmer's consent. This table provides the existing issue problems encountered during the monitoring, identifying, and classifying prevention of rice crop diseases. For another image, the figure 2 shows an example of leaf images from the crop dataset. and it represents the every crop disease randomly selected from the classes. So I have there the classes, which is 52 classes of rice crop diseases, and 1 class of healthy rice crop included in the study. Actually, in a total, it is 23 classes of images. Now, for the measurement requirements, in this study, it achieves to examine 2,300 images in total, including 2,200 images of diseases, crop leaves, and 100 images of healthy leaves sample. The data was obtained and combined through UC Irvine Machine Learning Repository and from Elsevier Mendeley Data Repository under Generalist Repository Ecosystem Initiative. And other images is captured and are contributed by the Department of Agriculture and by the researcher as well. And for the measurement requirements, throughout all the experiments, there are 4 approaches used in the study. Firstly, the entire rice crop dataset was divided into 3 partitioning, such as training set, testing set, and validation set. And secondly, each dataset is shuffled 1,000 times, which means that the data is randomly and orderly fed to model during the training. This enables the model to learn general patterns in the data rather than memorizing precise order or the precise order of the classes. Then thirdly, for each set, the study employs an auto-tune, which aids to determine the number of layers to be automatically fine-tuned for a target dataset in order to improve transfer learning. And lastly, image augmentation was used to artificially enlarge the dataset provided in this study. This aided the investigation given a dataset with sparse data samples. And for the classification process using convolutional neural network, this table shows the dataset partitioning during trial results. For the dataset partitioning, the researcher partition the data from 80% to 20%, 80% for the training set, and 10% for the testing, and 10% for the validation. And for the accuracy, loss accuracy, it provides 61.28% with a highest accuracy of 100%. While the data partitioning in the second trial result, the researcher partition the data by 60-40, 60 for the training set, 20 for the testing, and 20 for the validation set. The accuracy provides in the lowest value, which is 44.64, and with the highest value of 100%. And the third trial result, the researcher partitioned the data by 50 by 50, 50 for the training set, 25 for the testing set, and 25 for the validation set. It gives an accuracy of a lowest value, which is 83.29%, and the highest value of 100%. For the fourth trial results, the researcher partitioned the data by 40-60, 40 for the training, 30 for the testing, and 30 also for the validation. And it provides accuracy in the lowest value, which is 43.33, and got the highest value of 99.86. And lastly, for the trial result, the researcher partitioned the data by 20-80, 20% for the training, and 40% for the testing, and 40% for the validation set. And it gives an accuracy result with a value of 39.3% and the highest of 99.84%. So as you can see in this classification process and trial result, the highest accuracy is by partitioning the data set by 50 by 50, having 83.29% and 100% as the highest. Next figure is, this diagram depicts the entire CNN process employed in this study. So similarly, in the study of Zhang 2018, the researcher also applied different layers, the convolutional layer to take the input of the image features and extract them, and then also subsampling layer, also known as pooling layer, which be added between each successive convolutional layer, and the fully connected layer, also known as classifier, to receive the output of the upper layer, which presents the featured map of the higher level features and determine from which category these features best fit. So I have here the feature extraction, the input image feature extraction, and then the classifier, and the final predicted class or label of predicted disease of rice crops. Next is, I also have the literature review that it shows in figure 4. I have there 9 authors with work done and their accuracy outputs. As you can see, based from this literature, related literature, it only gives 99.4 as the highest accuracy provided, while in my study, it provides 100% of accuracy and with a lowest of 83.29% accuracy. So this helps the researcher to compare with other existing literature with the summary of their works and accuracy. Then the proposed architectural framework used in the study. So the researcher provide a flow chart to propose a mobile application to classify rice crop diseases. So the flow starts by accessing the mobile application. Then the user may choose to access the gallery or by capturing an image using their digital camera. And then the CNN will work and train the model, and then the application will try to classify the image if it is classified as one of those classes in the data set. If not, it will go back to the convolutional layer and learn another or train another model until it classified as one of the classes or data set. And then the final result is to view the classified disease with accuracy result. And then for the another figure, I have there the block diagram for the proposed architecture framework. So this diagram depicts how the system captures or uploads in image before processing it with image augmentation. And then the diagram also shows how the system trains and validates the model, as well as how the accuracy for the final prediction is evaluated and compared. As you can see, the data partitioning is 50 by 50, using also the modeling, training, and validation with 50 epochs. And then for the conclusion, the proposed architectural framework for classifying rice crop diseases in this study will help the Department of Agriculture and the farmers identify and classify rice crop diseases for early disease prevention. Implementing this architectural framework will result in a low maintenance, flexible, and simple to implement mobile application that is effective and cost effective for most especially for rice growers. And again, I miss Joyce Malubay, and thank you for the day. Have a nice day.
Mohammed Ozer. I'm from City University of Hong Kong. I will be sharing with you our ongoing research about using attribution theory to explain innovation performance. Basically, when we talk about innovation, we are talking about two different things. One is the innovation, which is about the product innovation, is about innovating the things that we offer. And product innovation is usually more uncertain, risky, challenging, and rewarding. Of course, it is the more interesting, exciting because it's external, whereas process innovation is more internal. We did a excuse me. We did a survey, cross-sectional survey study among Chinese Hong Kong firms, covering from different business sectors. We found that product innovation is really important for the Chinese companies as well, similar to Western firms. and a large proportion of companies' annual sales come from their new products. So this is the attribution theory. In other words, nearly 1/4 of companies' annual sales can be attributable to their new products. In other words, if these companies are making $100 a year, $25 come from their investment in new products. Or in terms of profits, likewise, almost the same. 1/4 of their annual profits can be attributable to their profits. But at the same time, only 45% of the new products introduced to the market can survive. That means that the success rate is very, very low, whereas the success rate in the US is around 60%. So what can we attribute? So using the attribution theory, what will be attributions? What will be the factors attributing to the unsuccess of these products? Basically, so in order how to innovate, so then we need to have a strategic mindset. We need to have a detailed plan, including process, including organization structures, key functional units, new product development activities. Let me briefly talk about these issues that can attribute to the success of product innovation. First of all, we need to have innovative and creative mindsets. In other words, do we believe in innovation? Are we willing to engage in innovation? Do we have the right attitude towards innovation? And are we up for the challenge? Product innovation is really challenging. I will skip this part. So we need to have a strategic, like any other business initiative, like investments, we need to have a strategic mindset. In other words, we need to be very clear about objectives, such as increasing market penetration, capitalizing on a new technology, capitalizing on existing markets, preempting an emerging market segment, or utilizing an excess capacity. More than 10 different objectives that we can pursue. But when we survey the Hong Kong firms, Chinese firms listed in Hong Kong company stock exchange, we see that they pursue only one type of objective: increasing market penetration. This means that they emphasize exporting. Among the manufacturing firms, almost the same pattern among service firms, and a similar pattern among trade firms. The challenge is that, because objectives differ with respect to their risks and with respect to the amount of resources, I think it is recommended to pursue multiple objectives. If you rely on experts only, if there's a trade war, right, then you need to find a way maybe to target your domestic market, as the Chinese firms are now struggling. So in terms of the plans, there are different dimensions, which is the use of a new product process, organizational structure, key functional units, new product engagement in product innovation activities, and using different tools. In terms of the process, this is a typical process companies need to go through, namely identifying an opportunity, coming up with new product ideas, doing a conceptual testing to decide whether it's a good idea or not. After that, if it is confirmed it's a good idea, they engage in design and development, and finally, they introduce a new product to the market. At the earlier stages of this process, the risks and uncertainties are really high. But as companies invest, the risk and uncertainties would get lower. So we asked the these Chinese firms whether they use any process. Unfortunately, most of them said no. Nearly, I think, like 60% said either no process at all or some informal process. The same pattern among service firms and similar patterns. Maybe trade firms use a little bit cross-functional teams, cross-functional process. So the challenge with this kind of a result is that maybe that can also explain why Chinese firms fail in terms of their product innovation activities. So it is important that we need to use a formal process. If you use an informal process or no process, there's a very high chance that we might organizational structure. This is important from the Western literature that we structure in a way in the company that we engage in different functional units. It must be because product innovation requires the expertise of different functional disciplines. If you rely on one single discipline, we might be maybe overlooking at some of the important technical or financial or marketing details. So we asked these Hong Kong firms, in the Chinese Hong Kong firms, and then they use, pretty much single function or a combination of different functions or some committees. I think that the biggest challenge was among the service firms. They either had a committee or they rely on a single function. That means instead of utilizing cross-functional expertise, they are heavily relying on the expertise of one single function. And trade firms are a little bit better. They use combined functional units or a group or a venture team. Another point is that key functional units, who will be responsible, who will be in charge of the product innovation? Is it marketing, R&D, engineering, planning? So we asked these people primarily among the manufacturing firms, marketing or R&D or engineering were responsible, in charge. Obviously, they emphasize the marketing and technical aspect. Probably they ignored the production and planning side. Among the service firms, they emphasize marketing or planning. Among the trade firms, again, there was a heavy emphasis on the marketing, R&D, and engineering. Again, this is not suitable. That can also explain why the success rate is so low. Another dimension that we look at the different activities. Product innovation is a long process. We need to have several different activities, such as idea identification, generation, custom testing, so on and so forth. We asked them, so this 11 activities, we asked these Chinese Hong Kong firms whether they use any one of these or all of them or some of them in the product innovation activities. Ideally, we need to use all of them because they all have different purpose in the process. So again, among the manufacturing firms, we see a heavy emphasis on the product development stage. Among the service firms, we see a heavy emphasis on the idea generation, product concept screening, but low emphasis on the volume forecasting, for example, market testing. Ideally, this should be a circle. But you can see some areas are missing. And this is also more obvious among trade firms, especially in the case of commercialization. they emphasize, as I said, this should be a circle. Ideally, should be a circle because each activity these 11 activities play different roles. If you compromise one aspect, then the quality or the success of the products will also be compromised. So as you can see, these trade firms emphasize some activities and they ignore other activities. Okay, let me wrap up. Finally, we also ask people the types of tools that they use. There are many different tools because this different it's very hard to understand the buyers, competitions, suppliers. So we need to if you use different tools, I will skip this part. Basically, there are different tools: brainstorming, conjoint analysis, Delphi. These kind of tools help us make correct decisions. Because each tool plays a different role, they are all important. But as you can see from this chart, we don't have this ideal circle. We need to have a circle, whereas this shows that manufacturing firms emphasize brainstorming. This shows service firms emphasize brainstorming or focus groups, and then the same pattern. That's why we can see why the success rate is so low among the Chinese Hong Kong firms. For your kind attention, if you have any question, you can always contact me. I will leave my details in the chat room. Thank you.